In this video, we are going to review the topics that are covered in Unit 5 of the AP curriculum. This mainly has to do with the idea of writing classes. So we're going to talk about constructors, we're going to talk about documenting your code by using comments, we're going to talk about accessor methods, whose job it is to go and get the value of a variable without changing it. We're going to talk about mutator methods, whose job is to go and change the value of one of our class variables. And then we're also going to talk about other methods. Some methods, it's their job just to print stuff out or whatever, so it doesn't fall into the accessor or mutator category. We're going to talk about static variables and methods, what their purpose is and how to use them. And we're going to talk about the keyword this, which has a very particular meaning in Java, and how and when to use that. So the first thing we're going to do is we're going to talk about the keywords public and private. So those keywords are access modifiers, and they determine who has access to the attributes and methods for a class. So you can put these in front of variables, and you can put these in front of methods, and it determines who gets to use them. Whenever you're saying the word public, that means that variable or method can be accessed from anywhere. So within the same class, from the main method of the same class, from other classes, from the main methods of other classes. Private means that you can only access those variables from within the class that you're in. So if you're in the dog class and you make a private variable, you can only access that directly through the dog class. If you're in a different class, like a cat class, could not access private variables or methods from the dog class. If you do have a private variable in the dog class and you'd like to get it from a method in the cat class, you'd have to run through a public accessor method. And that's one of the reasons for having accessor methods, so it can provide you with data that you deem fit for other classes to know. There is a third access modifier called protected, and protected is when you can access the information from within your class or any derived class of your class, but that's not covered within the scope of this AP curriculum. Classes are automatically public even if you don't put that keyword in front of them. So if you just write class dog, it is understood that that is a public class. One of the tricky things about the word public, though, is if you have multiple classes in the same program, putting the word public in front of the class tells Java that's the one that it should be looking to be in control of the program. So that's the one you'd want the main method to be in if you have multiple classes in the same program. Class variables are sometimes referred to as attributes, and you usually want to keep these hidden, so we would usually use the word private in front of them. So most of the time when you're writing a class, in order to do data hiding, you want to keep those class variables private. That's the usual way to construct your class. Constructors usually need to be called from outside of the class, so you usually want your constructors to also be public, so that we can get them from wherever we're at. How am I going to create a dog object from somewhere else if the dog constructor is not public? That would be a real tough sell. All right. Other methods, for your mutator methods and for these other methods that don't change or access a variable, you have to decide where you'd like to call them from. Okay, so where you're planning on calling them from decides whether you want to make those public or private. So that is something that we have to think about in the design phase of our class. What do we want to be able to do? Where do we want to be able to get stuff from? That's going to determine the public-private access modifiers that you should pick. One of the big ideas that we learned early on in our study of the Java is the idea of something called encapsulation. Encapsulation says that your class should keep to the details that your class is responsible for. And it should keep data hidden, but provide a way to get at that information from outside the class. So basically, the best way to do this is to make your variables private, but provide public accessor and mutator methods And you could put branching inside of these accessors and modifiers to decide whether or not somebody from an outside class would be worthy. For example, if we're talking about a bank account class and somebody wants to check their balance from outside the bank account class, you may decide to put in an if statement and check their PIN number to make sure that they are the correct person who should be seeing that information. So we make them jump through hoops in order to get to the information only if they pass like certain tests or whatever. An object's state refers to the values that are currently being stored in your class variables, or sometimes people call them attributes, at that particular time. Now remember, the state can change. So if somebody runs a mutator method and changes what the bank account balance is, then your state just changed because you changed one of the class variables. Constructor methods are used to set the initial values for all of the class variables. So when you run a constructor from a class, at that time, it should be decided what are the values that this object is going to store. However, remember, those are just the initial values. You may come back later with a mutator method and decide you want to change those. When no constructor is provided, Java provides a default constructor that gives all the intrinsic types their own default value. Now, for numbers, like integers and doubles, that means you're going to be getting zeros. And for user-defined variables, that means you're going to be getting null. The default type for Booleans is false. And those are pretty much the only ones that you would need for the AP curriculum. Documentation means leaving behind comments. And we have two types of comments. We have built-in comments, where you put a double forward slash, and anything that comes behind that is not read by the computer. And we also have header comments, which you use a forward slash asterisk to start the header comments. And you can write as much stuff on as many lines as you want, and you would finish those comments by putting the reverse order asterisk forward slash, and that would end the comments. So the reason for leaving behind comments is you can give people information about what to do with your code, or sometimes that information might even be for yourself if you're in the middle of writing the code and you're trying to tell yourself where you left off. When asked to write the free response questions, you will be given what are called preconditions and postconditions. Preconditions are things that have to be true prior to the execution of the code. The code does not need to check to make sure that these things are true. So anything that they list in their AP questions as a precondition, you can assume has already happened, and you don't need to have any kind of logic to test it out. A postcondition is what must be true after the execution of the code and gives us an idea about what must be returned from the code. So oftentimes, the postcondition tells us what should come back after the method is run. Accessor methods allow other methods the ability to access an object's value, especially if we've made those variables private and we're in a different class. The only way we can get to that information that we might need is by running through a public accessor method. And mutator methods allow other classes the ability to change an object's value. Again, if our variables are private and I'm in a different class, I do not have direct access to go in there and modify the values that we're storing. So I'd have to run one of the public mutator methods in order to be able to do that. One of the things that they love to test on is knowing how information is passed into a method. Intrinsic type parameters are passed by something called value, which means what we're actually sending into that method is not the value itself. We're sending a copy of the value. Therefore, if in that method you decide that you want to make changes to the value of that, it does not affect the original value that you were storing from before the method's execution. So if you're somewhere else and you define a variable called x, let's say integer type, it's got to be an intrinsic type, and x is equal to 2, and you pass that into a method, but then decide to change that value somewhere in the method, because it was passed by value, that change does not stick. So you'll still end up with 2 after the end of this execution. However, user-defined objects are always passed by reference. And what that means is you're not actually sending a copy, you're sending the reference to the memory location or the memory address within the RAM. So if somebody does decide to make changes inside of the method to a user-defined object, and this would include objects of classes, this would include strings, this would include arrays and array lists. These are all user-defined objects. Those changes will stick because you've actually sent the memory location. And so when somebody in that method makes changes, they're actually making changes to the values that the memory locations are storing. Some methods you write do not return class variables or alter them. For example, maybe your method is just intended to print out a bunch of stuff. So like an example of this would have been our volume and surface area methods that we had calculated for our different kinds of three-dimensional shapes. So they're not accessors, they're not modifiers, their job is just to print out information. So you can write methods like that as well. The toString method is a method that's inherited from the mother of all classes called object, capital O object. And you can override that in your class to print out whatever kind of information you like about your object. Now remember, the return type for the toString method is a string. So you get to decide and concatenate together any information that you'd like to tell people about your class. So that when the toString method automatically gets called whenever somebody does a system.out.print or a system.out.print line, and what's inside of the parentheses is some kind of user-defined object. So whenever these two things, system.out.print or system.out.print line, gets called and you pass an object inside of the parentheses, Java immediately looks for the toString method. Now, if you have not overridden the toString method in your class, the mother of all class objects does have a toString method, and what it prints out is information about where the memory location is in the RAM. So it's a confusing jumble of letters and numbers. But if you've overridden the toString method, you can decide what gets printed out about your class information. All right, the next idea that we're going to talk about is the word static. Now, the word static can be used in front of variables, and the word static can be used in front of methods. If you put the word static in front of a variable, that means that variable belongs to the entire class as a whole. So instead of having people's individual bank balances, that would be a non-static variable because everybody's bank balances would be different. If you want to have a variable that said total number of bank accounts, everybody's bank account should be able to say what the total number of bank accounts is, and it should be the same for everybody. That's the idea of a static variable. So all the objects that are ever created in this class will share the same value of that static variable. So no matter how many different bank accounts I make, they would all have access to the same number. If you change that number for one account, it changes that number for all the accounts. Now, static methods are associated with the class as a whole. Therefore, they cannot access or change class variables since they are specific to one particular object. So for example, the deposit method in the bank account class, you would not want to make that static because when you make a deposit, it's only going into one person's account. Static methods are something that all of the accounts would have to do. So static methods cannot change individual class variables, nor can static methods call non-static methods. If you are in a static method, you can't use it to call a non-static method because you do not have a particular object associated with you. So how are we going to know whose object to run the non-static method on? However, static methods can access and change static variables since they do belong to the entire class and they're not specific to one particular object. Access a static variable, to access a static variable, you use the class name and then dot variable. To run a static method, you use the class name dot the method name. Okay, so instead of having an object dot variable, it's the class name dot variable. Instead of an object dot method, it's the class name dot method because they belong to the entire class. The scope of a variable refers to where it can be used. Remember that local variables are declared inside of a method and can only be used inside of that method. This includes parameters, by the way. Class variables, those are variables defined outside of a method, can be used in any methods of that same class. And again, whether they're private or public will determine if they could be used outside the class. When a local variable and a class variable have the same name, Java will use the local variable, okay, unless you put the word this in front. So for those people who like to name their parameters, their constructors, exactly the same as the names of their class variables, that's when you want to do something like this.name. So this.name is actually referring to the class variable name as opposed to the local variable for name. All right, with that review, you are now ready to try the questions in the Unit 5 personal checks, parts 1 and 2. Give those a try, and then we'll go over the solutions in a few days.